Let's take a look at this problem. A culture of bacteria grows at a rate proportional to its size. Initially, there are 25,000 bacteria present. After 2 hours, there's a lot more, 125,000 bacteria. Two-part question, find the number of bacteria after 7 hours, and then find the rate of growth after 7 hours. Okay, so to get this problem started, we see that the number of bacteria is going to follow the formula P naught e to the kt. The reason that happens is because the culture of bacteria grows at a rate proportional to its size. So we know that P prime of T is equal to K times P of T. The rate of growth is proportional to its size, and the solution of this differential equation is going to be P of T is equal to P naught e to the KT. All right, now the initial amount is 25,000, so that's the easy part. So P of T is equal to 25,000 times e to the KT. Now, to solve for K, we will use the fact that after 2 hours, there are 125,000 bacteria present. So 125,000 is equal to 25,000 times e to the K times 2. And so dividing, we get that 5,000, excuse me, not 5,000, 5 is equal to e to the 2K. So natural log of 5 is equal to 2 times K, and so K is equal to 1/2 times the natural log of 5. Okay, so that we have our constant K and we have our proportionality P. So now we can switch over and start talking about our two problems. Find the number of bacteria present after 7 hours. So P of T is equal to 25,000 times e to the 1/2 times the natural log of 5 times T. And so P of 7 will be 25,000 times e to the 7/2 times the natural log of 5. And so that is going to be the answer. Now we plug that into our calculator. Hopefully I don't make a silly mistake with punching this in. So 25,000 times e to the 7/2 times the natural log of 5. And that works out to be something in the 6 million range. So that works out to be approximately 6,987,712. And so that'll be the number of bacteria after 7 hours. Okay, part two of the question is to figure out the rate of growth of the bacteria after 7 hours. So there are two ways of going about doing this. First way is to calculate the derivative, P prime of T. The derivative of this function is going to be 25,000 times e to the 1/2 natural log of 5 to the T times the derivative of the inside, which is 1/2 times the natural log of 5. And so that simplifies as 12,500 times the natural log of 5 times e to the 1/2 natural log of 5 to the T. And therefore, P prime of 7 will be equal to 12,500 times the natural log of 5 times e to the 7/2 natural log of 5. And so we can plug that into our calculator and get the answer. So let me go ahead and do that. So 12,500 times the natural log of 5 times e to the 7/2 times the natural log of 5. And that works out to be about 5,623,145 bacteria per hour. Okay, now that is the correct answer. Here is an alternate way of doing the second part of the problem. Find the rate of growth after 7 hours. We can use the fact that the rate of growth is proportional to the current amount. We know that P prime of 7 is going to be equal to K times P of 7. K times P of 7 we just got. So K is equal to 1/2 times the natural log of 5 times P of 7, which is 25,000, times e to the 7/2 times the natural log of 5. And if you'll notice, if you compare these two answers, they are exactly the same. 25,000 divided by 2 is 12,500. Natural log 5 matches, and then there are the exponentials. And so this is a alternate way of figuring out the rate of growth using the fact that the rate of growth is proportional to the current amount. So both techniques work for finding the rate of growth. Pick one that you like. Given if it was me as a student, I probably would do it this way, but both techniques work. Certainly this way is faster, but both techniques work and will provide the number of the rate of growth in bacteria per hour.